How do antiviruses work? So I was thinking about viruses recently, and wondering how exactly antiviruses keep up. Considering anybody who'd been coding for a few weeks could hack together something do nasty things to somebody's PC, the quantity alone would make a simple list of hashes prohibitive. So how do antiviruses do it? Do they monitor process activity and have a 3 strikes rule for doing virus-like things? And if so, what's stopping it from triggering on perfectly harmless things, like me moving files around in \system32? I did a bit of Googling, but the regular places didn't particularly help, and I couldn't find a dupe here, so I thought it'd be good to ask Smile.
This article from 2002 talks about building an antivirus engine. The article will describe the basic ideas, concepts, components and approaches involved in developing an antivirus program from scratch from a developer's/software engineer's point of view. It will focus on the main elements of an antivirus engine, hereafter referred to as ARV engine, and will exclude aspects like graphical user interfaces, real-time monitors, file system drivers and plugins for certain application software like Microsoft Exchange or Microsoft Office. Although ARV engines running/scanning for single platforms, such as Parmos or Epoch/Symbionos, can be designed in the same way, this article will focus on designing multi-platform scanning engines, which are far more complex. There's also an article on heuristic techniques to detect infections. It's also an interesting read.
About a year ago I attended a lecture by Mikko Hyppönen, one of F-Secure's main researchers. He showed their automated testing network, where they create virtual machines for every sample sent to them, analyze its structure, let it run, log everything it does, cross-reference it with previous samples and generate a summary for a human to check later. If the human concludes that it's a virus, the system automatically generates the detection signature and sends an update to the customers. I imagine other vendors have similar systems as well to keep their signature databases up to date.
From How Does Antivirus Software Work? Antivirus World. An antivirus software program is a computer program that can be used to scan files to identify and eliminate computer viruses and other malicious software, malware. Antivirus software typically uses 2 different techniques to accomplish this. Examining files to look for known viruses by means of a virus. Dictionary identifying suspicious behavior from any computer program, which might indicate infection. Most commercial antivirus software uses both of these approaches, with an emphasis on the virus dictionary approach. Virus dictionary approach. In the virus dictionary approach, when the antivirus software examines a file, it refers to a dictionary of known viruses that have been identified by the author of the antivirus software. If a piece of code in the file matches any virus identified in the dictionary, then the antivirus software can then either delete the file, quarantine it so that the file is inaccessible to other programs and its virus is unable to spread, or attempt to repair the file by removing the virus itself from the file. To be successful in the medium and long term, the virus dictionary approach requires periodic online downloads of updated virus dictionary entries. As new viruses are identified in the wild, civically minded and technically inclined users can send their infected files to the authors of antivirus software, who then include information about the new viruses in their dictionaries. Dictionary-based antivirus software typically examines files when the computer's operating system creates, opens, and closes them, and when the files are emailed. In this way, a known virus can be detected immediately upon receipt. The software can also typically be scheduled to examine all files on the user's hard disk on a regular basis. Although the dictionary approach is considered effective, virus authors have tried to stay a step ahead of such software by writing polymorphic viruses, which encrypt parts of themselves or otherwise modify themselves as a method of disguise, so as to not match the virus's signature in the dictionary. Suspicious behavior approach. The suspicious behavior approach, by contrast, doesn't attempt to identify known viruses, but instead monitors the behavior of all programs. If one program tries to write data to an executable program, for example, this is flagged as suspicious behavior and the user is alerted to this, and asked what to do. Unlike the dictionary approach, the suspicious behavior approach therefore provides protection against brand new viruses that do not yet exist in any virus dictionaries. However, it also sounds a large number of false positives, and users probably become desensitized to all the warnings. If the user clicks accept on every such warning, then the antivirus software is obviously useless to that user. This problem has especially been made worse over the past 7 years, since many more non-malicious program designs chose to modify other X's without regards to this false positive issue. Thus, most modern antivirus software uses this technique less and less. Other ways to detect viruses. Some antivirus software will try to emulate the beginning of the code of each new executable that is being executed before transferring control to the executable. If the program seems to be using self-modifying code or otherwise appears as a virus, it immediately tries to find other executables. One could assume that the executable has been infected with a virus. However, this method results in a lot of false positives. Yet another detection method is using a sandbox. A sandbox emulates the operating system and runs the executable in this simulation. After the program has terminated, the sandbox analyzes for changes which might indicate a virus. Because of performance issues, this type of detection is normally only performed during on-demand scans. Issues of concern. Macroviruses, arguably the most destructive and widespread computer viruses, could be prevented far more inexpensively and effectively, and without the need of all users to buy antivirus software, if Microsoft would fix security flaws in Microsoft Outlook and Microsoft Office related to the execution of downloaded code and to the ability of document macros to spread and wreak havoc. User education is as important as antivirus software. Simply training users in safe computing practices, such as not downloading and executing unknown programs from the internet, would slow the spread of viruses, without the need of antivirus software. Computer users should not always run with administrator access to their own machine. If they would simply run in user mode, then some types of viruses would not be able to spread. The dictionary approach to detecting viruses is often insufficient due to the continual creation of new viruses, yet the suspicious behavior approach is ineffective due to the false positive problem. Hence, the current understanding of antivirus software will never conquer computer viruses. There are various methods of encrypting and packing malicious software which will make even well-known viruses undetectable to antivirus software. Detecting these camouflaged viruses requires a powerful unpacking engine, which can decrypt the files before examining them. Unfortunately, many popular antivirus programs do not have this and thus are often unable to detect encrypted viruses. Companies that sell antivirus software seem to have a financial incentive for viruses to be written and to spread, and for the public to panic over the threat. I like this article, and I just copy and pasted from Antivirus World.
Foshi, your question is very interesting, but I suggest you to start your quest with another one. I'm advising this because the answers to the question you have asked can mislead you. I suggest you to start with thinking about what do you consider a virus, what's its definition? Elite virus writers are security researchers, not script kiddies. Their virus definition is, a virus is a piece of code that can multiply itself. That's it. As you can see, there are no destructive features mentioned here. All viruses mandatory being evil, that's FUD you get from proprietary antivirus makers so they could sell their software. It's wise to treat viruses as a part of the whole software ecosystem, not as outside evil aliens.